Hey everyone, Ben from JangaFX here. In today's video, we're going to be looking at how noise works and how you can use it to improve the look of your simulations. Now you might be a seasoned pro of a few years, or you might be completely new to EmberGen, but I hope that you take something useful away from this video. So to start with, we've got a roughly default scene. I've changed our default scene slightly to give us a larger domain to work in, and I've also amped up this noise slightly just to make it more evident what's going on here. So noise is really something that we can use to artificially inject some motion into our simulation. If I go ahead and just remove this noise node, then it won't completely calm down, but it will calm down a fair amount. So, how come we've still got all this vorticity happening, even though there's no noise in here? Well, the vorticity is really just the bread and butter of how EmberGen works. It's all about the equalization of pressure. If something moves up, then the pressure is negative in the voxel beneath it. And that attempts to equalize by pulling something back into it. That's what gives us these curls and this motion in the smoke. We can reduce the effect of what we see here even further by going over to our simulation node, onto our vorticity tab, and completely removing that vorticity intensity. It won't go away completely, but you can see that it's greatly reduced. You might also note that at this stage, this is really quite symmetrical. Anytime there's a blip, it happens on both sides. That's because our emitter and the primitive that's feeding it are directly in the center of our bounds. So things like differences in pressure are happening on both sides. Once you inject noise into it, you kind of nix that out. It won't happen anymore. So we've simplified absolutely everything. Let's have a look with our Gizmo to see what's actually happening inside our simulation. So if we go over to Visual, enable our Gizmo, we can see these arrows. Yours might not look like this. I tend to default to the 2D grid. I find it a little bit easier to read. So we can see that there are no arrows in this empty space over here. It's because there's no movement. These are showing us, the movement and the temperature of what's going on. Now when we're down the bottom, there's really no movement here, but as we get above our emitter object, the heat starts to kick in, and that drives things upwards because of the buoyancy. I'm going to add a noise node into our simulation. Now our viewer will disappear right away, so if I go back to our simulation node, I'm going to enable the persistent Gizmo. And you can see that all of these arrows are going everywhere, but it's a good visualization of what's going on. If we actually go over to one of our empty spaces, we can see that, there's nothing happening over here, but there is movement. And that is the movement that's being injected into the simulation with our noise node. We can tell that this is coming from our noise node because if we, let's say, look at our bias, if we move this in Y negative, they should all start to face the same way. So yeah, that movement is definitely coming from our noise node. So when we brought that node in, it immediately improved the look of our simulation. I'm just going to turn it off for a second, let it equalize. We see that all of this stuff should start to disappear. And we can see that these strong arrows in the center come back. Now, if you run your noise too strong, then yeah, it will kind of overwrite this motion. So when using noise, you don't want to completely overdo it. Try and be quite subtle with it. Thankfully, there's a couple of features in our noise node that help us mask where this noise is going to be applied. And it's one of the cool features that I really like about noise. So if you select your noise node, head over to masking, you can see that by default, constant mask is set up to 100%. Constant mask is just shorthand for all three of these channels all at once. So it's saying, hey noise, affect everything in the sim. Let's turn this down to 0. The noise should then disappear again. And let's turn on velocity. Bring that all the way up. The noise node is now going to look at which parts of the simulation are moving fast, and it's going to apply the noise there. If we bring this down to 0 and then use our temperature mask, you can probably tell that that's going to find the parts of the simulation that have heat, and it's going to apply the noise there. And then lastly, if we use our smoke mask, it's not going to affect the flames, it's going to affect only the smoke. You will find that there is noise in here, but that's because we have smoke mixed in with the fire. Now for both of those last two, we've got handy ranges here, which are actually quite useful. So to make it really evident what's going on, I'm going to use a bias of say 5. I'm going to bring our amplitude up. So right from the off, with constant mask, everything's going in that direction. That's great. Bring it down to 0. So let's use the smoke mask. If we bring this up, then the smoke is going to start being affected by the noise and being pushed in a direction. Now let's say I want to affect the smoke, but definitely not the flames. Let's use our smoke range. Let's bring this down so that we gradually only affect the thinner smoke. we bring this down to a certain point, we'll start to notice that the flames will stand up, but the smoke will still be affected. There we go. Now let's add another one in. Let's add another noise node, but only affecting the temperature. So I'm just going to copy and paste. Plug this guy in. I'm going to change the mask that it's using. So we don't want a smoke mask. We want a temperature mask. You don't have to use 0 or 100, obviously. You can mix and match these as high and low as you like. Just to make it easy to visualize, I'm going to turn this to -5 so that we're pushing the fire in the opposite direction to the smoke. I'm going to look again at our masking, and I'm going to use our temperature range here. So I'm going to bring those lower temperatures out of the range. I want to only affect the higher temperatures. There we go. All right, so it's unlikely that you would try and do this in practice, but this is just so we can visualize what's going on here. I'm using this bottom node here to only affect the fire by affecting the temperature mask and a specific range, and I've sort of noodled around it to find the values that kind of work for the fire. And at the same time, there is this other noise node here that's got a bias pointing left, and that is only affecting our smoke channel. And I've used a specific range because if I have this range wide open, then it would also push the smoke that it's in with the fire, and that would push the fire to the left as well. So there you go. You can separate out which parts of your simulation you want to affect with the noise. Okay, let's do something with this that's actually useful, something that you might do in a simulation. So let's bring in a brand new noise force. Let's just check that everything is at default. Yep, it's constant is on, so we don't have a bias. This is all good. What I want to do is I want to break up these flames a little. I want to make them come apart, and I don't want to affect the smoke. So first things first, let's bring our constant all the way down, and let's bring up our temperature mask. And I'm also going to go over to our general tab, and I'm going to really ramp up this noise so I can definitely see that it's active. And if I bring up our Gizmo so that we can see inside the simulation to see what's going on, we can see that all this craziness is happening out here. We've still got some temperature up here, so the noise is also being applied here, but as a rule, it's not pushing the smoke. You can see that it's actually quite tame around here. So we pushed it to the side before, but I want this fire to go up, so I'm going to use our bias again on our noise node. And I'm going to push it up by, let's say 5, and then we'll disable our Gizmo so we can see visually what's going on. That's pretty cool. I might change some of these values here, so I'm going to bring in some more octaves. All right, cool. So we have isolated the temperature channel, and we are affecting on the Z-axis with a bias in this noise node. So we are pushing the hot bits up, and the rest of this smoke is largely unaffected. It's not being pushed upwards by that noise. It has some upward motion that it's carried with it from the flames, but after a while that would die out, and it would just sort of hang there. So the next thing I'm going to do is I'm going to break up this flame, and we can do that with our noise node. So I'm going to bring our scale down a bit, let's say 4 or something. I'm going to bring in some octaves. Also going to up our gain a bit, let's say 1.5. And that's just going to add, more small noise into our flames. Okay, so we're masking everything with the temperature, so anything happening in this noise node only happens within here. So that's isolating and directing the use of noise on a particular part of your simulation. We could actually do exactly the same thing for our smoke. So if we pin out forces here, we're going to use our masking, we're going to turn off constant. We're going to bring up our smoke mask. All right, cool. So now our smoke noise node is isolated only to the smoke, and it's pushing things off in Y positive over to the left here. Now we could bring our scale down, and that would really start to bring some detail into this thing. So let's pop it down to 2. And you'll see that things really start to break apart for our smoke here. So let's revisit Vorticity just for a sec. Let's bring this back up to 8. Back over to our simulation node, where we have our Vorticity tab. Now, that's all still off. So you might think that this is like a system level noise, a simulation level noise, but it's not really. This is more like an amplifier of the Vorticity that's already in there. If we bring back our visualizer, bring our Gizmo on, these arrows, when we enable Vorticity and when we pump it up, it's going to amplify all of these motions, and that's going to bring even more Vorticity into the simulation. So if we pop this up to say 10, it's not actually going to change the motion, it's not going to change where things are going, but when it comes to these small curls and things, it's going to amplify them. And the end result of that is even more crunchy, crispy details. So this is a nice way to get some extra detail into your simulation. Bearing in mind, we're only at one subdivision here. We haven't upscaled at all. So if we were to do that, so once we've done that upscale, we can see that we've got even more visual fidelity in our smoke. So there you go, the force noise node. You can do quite a lot with just one node, but when you start stacking them up on top of each other, for instance, we could use one with a scale of 16, one with a scale of 8, and then just keep subdividing down to bring more and more tiny details into your smoke. All right, before we go, we're going to look at how we can use noise in an explosion. I've just set up a very simple volume emitter based explosion. With that, it's just a square domain. I've got a simple primitive, tiny sphere, and it's pushing out a small amount of fuel, smoke and fire, and it's basically using pressure to push it outwards. So if I play it, it's going to be really boring because we turned off all of the noise. I've brought down all of the vorticity, so it's going to be a really simple looking puff. We're going to turn this into something that looks a lot more angry. So we're going to start by using our simulation node. We're going to bring up our vorticity. We're going to use the default of 5 to begin with. We can see that that already brings in a bunch of stuff. So let's ramp this up to say 25. And remember, this amplifies the vorticity that is already there. Too much and it starts to look a bit garbage. So maybe let's bring it down to 10. That's all right, we can work with this. We're going to use a noise node now. We're going to use a fairly low size. Let's go with 3. And let's mask it by our temperature. And we'll turn down our constant mask. Let's see, we've got amplitude there of 2. Let's ramp that right up and just see what the result is. So it's changed it quite a lot. I'm going to bring this back down to say 3. And I'm going to bring our vorticity right back down actually. Maybe 1. All right, I've upped the size of the primitive that's feeding our volume emitter. Seems a little better. So we're gonna up-res this slightly. So let's go to ×2. That's a bit more like it. Okay, and change our shading because I tend to go for the black body. There we go. And also bring in some translucency. Okay, we've got our force noise operating on temperature and velocity now. So it's affecting the hotter parts of the simulation. It's not so much affecting the smoke directly. I believe that it's going to be the flames in the explosion that are then affecting that smoke. It still seems a little bit small scale, so we're going to bring in some more noise nodes to break up this smoke a bit. So I'm going to shift this one over. All right, so we've brought up the smoke mask here. Let's crank up the amplitude a little. Let's bring in some octaves as well. That's pretty cool. But it does illustrate one problem with noise, especially in the context of something like an explosion where everything happens in one moment and then what you're left looking at is the aftermath of it, like a cloud moving upwards from it. And that problem is when we've got this noise enabled, especially for the smoke, this smoke here is constantly being affected by this noise. If you watch it, it's just sort of bubbling away. Now, that doesn't look particularly natural and wouldn't really be happening in real life. You would have this smoke suddenly shattered and broken up, but then it would just move along with the air currents. So what we're going to do is we're going to animate our smoke noise here. We're going to make it very, very powerful. And then as the explosion subsides, we're going to bring it right down so it stops moving. So we're going to affect the smoke, and then we're going to turn that noise off effectively. The noise will still be there embedded in the smoke, but we won't be introducing any more. So let's first figure out where our explosion starts and stops. So I think by the time the smoke is born here, this is where we need to reduce the effect of this noise. Remember, it will have an effect to begin with, and it will embed a load of vorticity into the smoke, but then it will stop adding it. And it will just leave it to sort of ride the wave of the explosion. So I'm going to use shift and click for our, let's go with our amplitude. So enable keyframes here. I'm going to shift click here. I'm going to shift click fairly soon after. All right, so at this point in time, we want it to be a force of 5. At this point in time, we want it to be a force of 0. So the 0 being the amplitude, that's the amount of force being applied to the smoke. And that looks much more natural to me. So it's still quite large noise there. I'm going to play with that in just a minute, but it's no longer bubbling away. So if we get rid of this guy and run it again, when you watch the smoke, it's almost like it's, you know, some witch's cauldron sort of bubbling away. So it's a good idea to add this keyframe after, just to reduce that effect right down to nothing again. So it's like you're stamping detail onto the explosion and then just letting it ride the simulation. Alright, cool. And now I'm going to start stacking these noise nodes that are affecting the smoke, because I want to be affecting it in different scales as well. So let's add another one in that's just a copy of the original, so it's all set up the same for masking, etc. Alright, cool. I have arrived at something that I'm quite liking. I haven't changed actually too much. I went into the combustion settings and I had a play around with them. Definitely recommend that. Things like increasing the oxygen in the fuel, you know, your explosion happens much quicker. Increasing your gas release so you have more expansion. So they can all have a great effect. I've also brought back the buoyancy so that when we explode, we definitely start to go up a bit quicker. I've actually included another noise as well, which is masked to the temperature. And that's actually pointing downwards. That's pointing in -Z. So it's affecting the hot parts of the explosion and it's fighting that buoyancy just a bit. Just keeping it down a little bit so that the explosion's got more time to evolve before it disappears off into the sunset. So, force noise node. Really, really handy. Really instrumental in building your effects. Don't forget to play around with keyframing the intensity, especially when you're working with explosions. You don't want it running the whole way through your explosion because it will give you that weird bubbling look to your smoke. And definitely play around with your masking settings. So getting a noise node to affect a particular part of your simulation. Okay, cool. I will leave the presets for this explosion and the fire as well, so that you can, you know, download them, tear them apart, have a look at what I built. I'll catch you in the next video.